We are grateful you decided to select our equipment. We are offering you to get acquainted closely with the delivery set of VD3-81 eddy current flaw detector. All component parts are delivered in a handheld bag. The standard delivery set includes the following equipment: electronic unit of VD3-81 flaw detector in a protective soft covering, automatic charger for charging the instrument battery, VD3-81 calibration block for setting up the flaw detector sensitivity, differential EC probe in a protective housing with a protector, operating manual for VD3-81 eddy current flaw detector. Before operating the instrument, carefully read the operating manual. Registration certificate for the flaw detector. Registration certificate for VD3-83.08 calibration block. Connection cable for electronic unit and PC, such as USB, mini USB. Reflection type cable for connecting the EC probe to the electronic unit. Protective covering protects the instrument from damages and dirt during the operation. To take out the instrument from the soft cover, open the zipper from the top. The nameplate with the manufacturer label is located from the rear panel of the instrument under the soft covering. The instrument can be switched on by pressing the power key from the front panel. Light and sound alarm from the front panel indicates the correct switch on of the instrument. To get a closer look at VD3-81 flaw detector, take it out from the soft covering. To lift the soft covering from the flaw detector, unzip the wraparound zipper from the case top. Now have a look at flaw detector connectors and their functionality. The right side panel of the flaw detector includes the connector for the headphone with a microphone, charger connector, on the flaw detector rear panel under the protective cap, there is a mini USB for communication with PC. On the left rear panel there is a nameplate with instrument number and manufacturer's information. The left side panel includes the connector for the cable of absolute type probe, encoder connector, connector for the cable for other types of EC probe, and rotary scanner. VD3-81 Eddycon is equipped with the replaceable battery. Let's look closer to the battery replacement procedure. The removable battery is located under the cap in the bottom side of the rear panel. Unscrew the two fixing screws using a screwdriver. Take out the battery compartment cap. Now we have the access to the battery. To replace it, unscrew the support strip and disconnect the connector. When assembling, set the cap into the lower groove and fix it in the position that coincides with the holes. Tighten the screws using the screwdriver to fixate the battery compartment cap. The instrument front panel includes the keypad, color display, and alarm LED. To switch on the flaw detector, press and hold the power key until the relevant sound and light alarm is appeared. Now have a look at the flaw detector panel keys and their functionality. If one key is used for balancing the EC probe in the main operation mode, in other modes, follow the tips. F2 key takes to the full screen mode in the main operation mode. In other modes, follow the tips. F3 key is used for signal centering in the main mode. In other modes, follow the tips. Button for moving down through the menu. Button for moving up through the flaw detector menu. Button for changing the perimeter step. Button for increasing the selected perimeter. Button for decreasing the value of a selected perimeter. Button for the access to the menu items, archive, view, settings, and for returning to the previous menu level. Button for entering the submenu when pressing in testing mode. The current setup is saved as default one. This button automatically puts a display signal from liftoff. Button for changing the pages when operating in a mode of frequency mix. Button for moving left through the horizontal menu and for automatic setup of the perimeters of single coil, perimetric EC probe with switched on single input. Button for moving right through the horizontal menu. Differential type probe are used for testing the conductive materials with a flat surface for the presence of surface and subsurface defects. Connect the eddy current probe to the flaw detector using the reflection type cable. Make sure that red marks on the mating connector parts have been matched. The marks ensure the correct cable position during the connection. Differential eddy current probes are delivered in a protective housing to be protected from mechanical damages. The housing of eddy current probe can be dismounted by unscrewing the dismountable parts of the housing. The eddy current probe has its designation on the side surface where the operating frequency and probe diameter are indicated. There were resistant protectors located from the bottom side of the housing. Now the protective housing is completely dismantled. the assembling is performed in reverse order. When assembling the protective housing of eddy current probe, make sure the mark on the end surface of eddy current probe has been matched with the groove on the upper end of the protective housing. Switch on the instrument by pressing and holding the power key until the sound and light signal is appeared. Now move to the General Settings menu and select the type of a connected probe reflection. Return to the test mode. Set up the preliminary parameters for scaling the complex plane. Set up the probe frequency that is indicated on the probe housing. If required for convenience, you can use the step key. Set up the preamplifier and main gain. Set up the preliminary value of the generator voltage of the flaw detector. Switch off the filtering of signals. Set up the position for signals 0 point. The most suitable in our case is the center position. Set the alarm type circuit and set up its preliminary parameters, radius, select the filter type average and set the number of averages. Place the eddy current probe at the flow-free area of calibration block. Perform the balancing by holding the eddy current probe in a static position. Scan the block surface and, in a complex plane, analyze the signals received from the artificial defect. If the level of received signals is low, change the gain and voltage values. For the convenient signal display and analysis, if required, change the phase by moving the signal into the upper screen part. Perform the confirming balancing and scanning of the block surface. The flaw detector includes the persistence function for automatic clearing of screen data. To activate this function, move to the General Settings menu and set up the desired time interval for automatic cleaning of the screen. Return to the main test mode. Increase the scale for signals display in a complex plane. After the balancing, during the scanning, you can observe the clearing of a screen. For calibration, it is required to decrease the scan of a screen. As a result, the signal separation and display shall be more clear. Perform the balancing by holding the eddy current probe in static position. Carry out the scanning of a block surface from the smallest to the biggest artificial defect. To plot the curve for defect depth estimation, enter the calibration menu. In our case, the calibration shall be carried out by the amplitude and measurements in millimeters. Provided that the calibration curve to be created on the basis of signals received at calibration block, mark these norms and select the name of a required calibration block in a relevant STD menu item. By changing the parameters for the width and position of a measurement cursor, highlight the area of a signal from the first minor defect. Add the values of measured parameters in this area by pressing the relevant button. Perform the similar steps with other signals from artificial defects in a calibration block. The depth values are automatically set up in a matrix by pressing the F3 key by STD. Also, the depth of artificial defect can be manually set up. The calibration curve is plotted, and according to it, we can perform the estimation of defect depth. Place the eddy current probe at flow-free surface of a test object and perform the balancing. Carry out the scanning of a test object and receive the signals on the screen from defective areas. To estimate the defect depth, move to the View mode. Move the measuring gauge into the area of signals received from defect. Set up the cursor width and position within the first signal range. The measured defect parameters are displayed in the bottom information bar of the flaw detector screen. Similarly, perform the estimation of all other defects in a test object. If required, save the created flaw detector setup. For further convenient use, save the setup and assign the unique name to it. Rotary eddy current probes are used for defect detection in a test piece holes made of aluminum alloys, ferromagnetic and austenitic steel. Eddy current probes are driven by the rotary scanner, which is connected to the flaw detector through this specialized cable. Make sure that red marks on the mating connector parts have been matched. The marks ensure the correct cable position during the connection. When inserting the eddy current probe, make sure that the marks on the probe housing and rotary scanner have been matched. While inserting, press the probe until tight. Switch on the instrument by pressing and holding the power key until the relevant sound and light signal is appeared. The menu with the list of available scanners shall be appeared on the screen. Select the connected scanner from the list. Set up the probe frequency. Set up the values for the main and preamplifier gain. Set up the value for generator voltage. Switch off the data filtering. Place the position of complex plane center on the center of the flaw detector screen. Open the General Settings menu and set up the parameters for the automatic screen arrays. Set up the rotating speed for the rotary probe. Avoiding the eddy current probe touches the foreign parts, press the balancing button. Insert the eddy current probe into the calibration hole of a calibration block perpendicular to the surface. Switch on the probe rotation by pressing the button from the scanner side face. Receive the signals from artificial defects on the flaw detector screen by performing the scanning along the hole. Select the band pass filter and set up its parameters. And perform the confirming scanning of a whole surface, having performed the balancing. For better visualization, we are changing the scaling parameters for the screen active area. If required, change the rotating speed for the eddy current probe. Also, it is possible to change the phase value. Select the alarm type, secular, set up its parameters based on the signal level received from artificial defect. The LED on the rotary scanner case also indicates the crossed alarm level. Move to the General Settings menu. And save the current flaw detector setup into the instrument memory by assigning the unique name to it. Absolute eddy current probes are used for testing the presence of surface defects. Use the LM00 cable to connect the eddy current probe to the flaw detector. After connecting the eddy current probe, switch on the instrument by pressing and holding the power key until the sound and light alarm is appeared. Now we move to the General Settings menu and set up the type of a connected eddy current probe LM00. Then return to the test mode. Set up the eddy current probe frequency. Its value is indicated on a probe housing. Select the preliminary scale parameters for signal display on a complex plane. By holding the eddy current probe in the air, press the key for automatic setup of a probe parameters and wait for the inscription to be appeared. Select the position for the reference point on a complex plane. For the absolute eddy current probe, the best position for the reference point on a complex plane is the right bottom corner. Set up the values for the preamplifier and main gain. Set up the value for the generator voltage. Place the eddy current probe at the flaw-free area for block perpendicular to the surface and carry out the balancing. When changing the inclination angle of a probe to the vertical scale, we shall achieve the signals from the probe distortion in a complex plane. Press the auto lift key that automatically puts the displayed signal from a lift off. At a repeated change of the inclination angle of a probe, the interfering signals are directed along the horizontal plane. After repeated balancing, we perform the scanning of a calibration block block surface. The signals received from the probe distortion shall be located in a horizontal complex and friendly signals in a vertical. Set up the parameters for the general scaling for the most convenient analysis of friendly signals. Increase the vertical scale parameter for the visual spread of signals. Set up the linear type of alarm and set up its parameters. In this case, we set up the height. Select the filter type averaging and set up the number of averages. Repeat the scanning of a block surface and inclination of a probe relative to the surface normal. Analyze the signal's position to determine the correctness of alarm setup. In our case, we should increase the vertical scale of complex plane. Thus, the signals reflected from artificial defects shall be easy to see. Repeat the balancing and scan the block surface. Adjust the values of alarm and gain parameters until the friendly signal crosses the gate. Now move to the Settings menu and save the current setup and assign the unique name to it. Weld type eddy current probes are used for testing the surface defects of welded joints. Use the bridge type cable to connect the eddy current probe to the flaw detector. When connecting the cable, the special attention should be paid on marks to be matched. Make sure that marks on cable connectors, eddy current probe housing, and instrument case have been matched. Switch on the instrument by pressing and holding the power key until the relevant sound and light signal is appeared. Now move to the General Settings menu and select Type of a connected probe bridge. Return to the Main Test menu. Set up the preliminary parameters for scaling the complex plane. Set up the frequency of eddy current probe that coincides with the value that is indicated on the probe housing. Set up the main and preamplifier gain. Set up the preliminary value of generator voltage. Place the eddy current probe at a flaw-free area of a block surface and perform the balancing by holding the eddy current probe perpendicular to the scanning surface. Scan the block surface and, in a complex plane, analyze the signals received from artificial defects. As the signals go beyond the screen active area, we should change the phase value. Carry out the confirming scanning and analyze the position of signals received from artificial defect. Change, if required, the position of initial zero point. Perform the repeated balancing and scanning of a block surface. Select the filter type, low frequency, and set up its parameters. Perform the balancing and scanning to define the level and type of alarm. Select the alarm type, linear, and set up its parameters. During the scanning process, check the correctness for alarm level setup. If required, save the created flaw detector setup. Assign the unique name for the saved setup for its further convenient use. The VD3-81 flaw detector is capable to operate in the frequency mix mode. To start the operation, connect the eddy current probe and switch on the flaw detector. Enter the General Settings menu and switch on the double frequency mode of flaw detector operation. Return to the previous insert and enter the Channel Setup menu. In the appeared matrix, if required, change the parameters. Of the first and second frequency and select the type of the frequency mix. Return to the main test mode. Now we are located on the first page of frequency setup, that is assigned with the digit 1 located near the 0 point on a complex plane. Set up the value for the first frequency in case it was not set up in the Channel Setup menu. Place the eddy current probe at a flaw-free area of a calibration block and by holding it in a static position perform the balancing. Carry out the scanning along the surface of a calibration block. If there is no need to change the parameters of a generator and receiving circuit, then move to the next setting page by pressing the relevant button. The digit next to the 0 point indicates the page number. Place the eddy current probe at a flaw-free area of a calibration block and by holding it in the static position perform the balancing. Carry out the scanning along the calibration block surface and analyze the signals received from the artificial defect on a complex plane. If required, change the parameters for the gain, generator voltage, or phase, and for achieving the desired result, perform the confirming scanning. Move to the third settings page. Here the signals of the first, second frequencies and of the mix of these two frequencies are displayed. Select the alarm type, circle, for the complex plane. Select the type of complex plane centers location on the flaw detector screen. Set up the alarm parameters radius. Place the eddy current probe at a far-free area of a calibration block, and by holding it in a static position, perform the balancing. Carry out the scanning along the calibration block surface and analyze the signals received from artificial defects on a complex plane. Directly on this page, if required, change the parameter values of the first and second frequencies. Carry out the confirming scanning of a calibration block surface after changing the input parameters of a testing. Also, the user is capable to change the type of a frequencies mix. Analyze the signals of a frequency mix after changing its type and carrying out the confirming testing. The scanning results can be saved into the flaw detector memory. The saved results can be reviewed on the flaw detector or PC. If required, save the created flaw detector setup. For further convenient use, assign a unique name to the saved setup.